Hello everyone. Today we are going to discuss one of my favorite topics, hypothesis testing. This will be a 4-part lecture series and this is the first video. In this video, we'll focus on hypothesis testing for one population mean for large samples. The objectives of our lecture today is to understand the concepts of hypothesis testing, to identify the appropriate test for one population mean for large samples, and to apply hypothesis testing when making decisions in your projects and in real life. Before we start, let's do a short review on the basics of statistical inference. So what is population again? All possible individuals or objects under study. Everything that you are interested to study about. And sample is simply a part of population. And I think you remember that statistical inference would be when you generalize anything that you get from your sample to your population with some degree of certainty. In your course, we'll discuss two types of statistical inference. The first one would be hypothesis testing, and the second one is estimation. This we've discussed in the previous lecture. Population parameter would be any numerical characteristics that describes your population. For example, your population mean, which is mu, and your population proportion, which is the lowercase p. Statistics or sample statistics would be any numerical characteristic from your sample. For example, your sample mean. We notate your sample mean using X bar, and the sample proportion P hat. Now let's review the symbols that we've used so far. For your population mean, again, would be mu, and sample mean X bar. Population standard deviation, sigma. Sample standard deviation, S. Population size, capital N, and sample size, lowercase n. Population proportion, lowercase p, and sample proportion, p hat. So, hypothesis testing begins with some theory or claim about a particular parameter of a population. Now, the parameter that we would discuss in engineering statistics would be mu and p. So, the population mean and the population proportion. So, the next step of hypothesis testing would be making decisions about the entire population based on your sample statistics. Based on your claim, you would be given some sample statistics or some sample data, or otherwise as a researcher you would be collecting some sample data, and from there you would accept or reject the claim that you have stated in the beginning of the study. The purpose of hypothesis testing is to find out whether a given statement or a given claim or a given theory from your population parameter, in your case mu and p, is true. Let's look at this example. It says that the mean income per month for all engineers in this country is ringgit Malaysia 3,000. Usually in statistics, the first step is to extract the information. So what is important here? The word all, right, which describes your population, and the word mean. So you might want to check whether the mean income differs from ringgit Malaysia 3,000 or whether the mean income is less than ringgit Malaysia 3,000, or whether the mean income is more than 3,000 ringgit Malaysia. So the next step is to conduct your hypothesis test. We start the hypothesis testing by making an initial assumption. This comes from the question itself, or as a researcher, it could be your own initial assumption. So there would be a given claim or statement. The next step is to collect evidence data. So as a researcher, you would collect some sample data, or it will be given in the question itself, in your exam. Based on the available evidence of your data, sample data, you would then decide whether the initial assumption, the initial claim, is true or false. So we start by discussing about our hypothesis. There are two types of hypothesis. The first one is called the null hypothesis. It's written as H0 here. The null hypothesis is also pronounced as H0, right? And the next hypothesis is called the alternative hypothesis. It is written as H1. The most important part, or the most important statement in the whole chapter, would be this one here. So what does it say? It says that the null hypothesis always states that the parameter, your mu or p, equals the value specified in the alternative hypothesis. So it means that your null hypothesis, for example, in your study, you would like to test the mean, right? So the null hypothesis would state that the parameter mu is equals to a value. So it could be any value, for example, 4. Now let's look at this example. A soft drink company may claim that, so this is the claim, alright? So we always start by highlighting the important information. On average, now this is another important information. We're testing the average. Its cans contain 12 ounces of soda. So 12 ounces of soda. A government agency may want to test whether the average is less than 12 ounces. Remember that your null hypothesis would contain the equal sign or symbol. So in this case, H null. And we are testing for average population, average mu, contains 12 ounces. So that means mu is equals to 12 ounces. And versus the alternative, the government agency would like to test whether the average is less than 12 ounces. So whether mu is less than 12 ounces. I hope this is clear for you. The testing procedure begins with the assumption that the null hypothesis is true. So we would always assume that the null hypothesis is true until we have some further evidence that says otherwise. The goal of hypothesis testing is to determine whether there's enough evidence that the alternative hypothesis is true. That means in this case, we are interested in determining whether mu is less than 12. So again, we start with the null hypothesis, which contains the equal sign, and then the alternative hypothesis, and we either could reject the null hypothesis, which means we accept the alternative, or we accept the null hypothesis, which means we reject the alternative. Before we move on further, we need to discuss some statistical terms for hypothesis testing. The first one would be the test statistics. So the test statistics would be a calculated value. Now this is the key point, a calculated value. That means it's a number based on sample information. So you get it from your sample data. It's denoted by Z star or T star. So this depends on your statistical distribution that you would choose to use in your study. We'll discuss this in a short while. So let's say we are going to use the normal distribution, which is also the Z distribution. So for your test statistic, I prefer to note a star here, right? Test statistics is simply a value, for example, 3. And this value is very important in determining your decision and your conclusion later on. The next term that we are going to learn would be the rejection and non-rejection region. So the sampling distribution that we would choose is divided into two regions, which are called the rejection and non-rejection region. So for example, we are choosing the normal distribution, and the rejection region is the level of significance, alpha. So the alpha is also the rejection region. And the one here would be the non-rejection region. Next, the regions are divided by a critical value. So this one here, this value here is called the critical value. If we use the normal distribution, then it's denoted by Z alpha. Then the next step would be to check whether the test statistics falls in the rejection or the non-rejection region to make our decision and conclusion. So we are now at a more interesting part of hypothesis testing. We would be determining the tails of your hypothesis test. This is very easy. You simply determine the tail of your hypothesis test by looking for the sign of the alternative hypothesis. So in this case, the alternative hypothesis says that mu is greater than 15. Now this would be our distribution. For example, we are using the normal distribution. Greater than is always on your right hand side. So the rejection region would also be on your right hand side. And this would be the rejection region of alpha. And this would be the non-rejection region. This point here would be the critical value, Z alpha. Okay, next example. Again, we are going to determine the tail of your hypothesis test. So we'll be checking out the alternative hypothesis. Mu is less than 12. Less would be towards your left hand side. So for example, we are using the standard normal distribution. Less is on your left. This is your alpha, also your rejection region, and so this would be your non-rejection region. This point here is your critical point, and remember your normal distribution, the mean is 0, and this value here would be negative Z alpha. I also forgot to mention that if your alternative hypothesis is less than, then the null hypothesis could either be equals to or the opposite of less than, which is greater or equals to. So you would choose either one. Okay, do not write both down. It's the same for when the alternative is greater than, then the null would be equals to, or you could write the null hypothesis as the opposite of greater than, which is less or equals to. And now we have the alternative as mu not equals to 3.5. So now our rejection region, when it's not equals to, we have two rejection regions, one on the right and the other on your left. And this would no more be alpha, this would be alpha over 2. Remember your confidence interval? Yes, something like that. And this would be alpha over 2. In this case, you have two critical values, z alpha over 2 and the other one negative z alpha over 2, and this would be the mean 0. So you have two rejection regions, one on your left, one on your right, and the middle would be your non-rejection region. Let's talk about the decisions that you would make, right? So when you reject the null hypothesis, you actually accept the alternative hypothesis, or you are in favor of the alternative hypothesis. And when you don't reject the null hypothesis, it means that you are in favor of the null hypothesis, or you accept the null hypothesis. So okay, I invite you to help me out with the exercise that we're going to discuss now. State the null and alternative hypothesis that should be used in the following claims. So let's look at the first claim. A lecturer claims that his students scored an average, now this is the keyword here, average, of 55 marks in their statistics test. Then the subject supervisor wants to know whether the lecturer's claim is acceptable. So what is the null and alternative hypothesis here? Average mu equals to 55. Remember, the null hypothesis must always have the equal sign. And the alternative would be, you want to check whether the lecturer's claim is acceptable or not. That means the opposite of equals to would be not equals to 55. Okay, next example. A car manufacturer claims that the mean, again the keyword here, the mean, selling price of all, so population mean, all cars manufactured cost only 80,000 ringgit. So the null hypothesis would be population mean is equals to, give me sure, 80,000. A consumer agency wants to test whether the mean exceeds 80,000. So that means the alternative would be that mu exceeds 80,000. We have here the claim that all 1.5 liters labeled bottles contains an average, this is the keyword, of 1.49 liters of soft drink. So the bottles are labeled as 1.5, but the claim is the average is 1.49. So this is the claim. A retailer wishes to test whether the mean amount of soft drink is less than. So this would be the alternative. So your null hypothesis would be mu equals to 1.49. The alternative is mu is less than 1.49. What if you were to test if the mean CGPA for all U10 students is more than 2.7? So what is the keyword here? Mean and all, that means the population mean is more than 2.7. So does more than contain an equal sign? No, it doesn't. So that falls in the alternative hypothesis, mu more than 2.7. So the null could either be equals to or the opposite of more than, which is less or equals to. And next, to check whether on average, so again, average, students spend less than 2 weeks to complete their assignment. So less than would definitely go to the alternative. Average is mu, 2 weeks. You could write weeks here. Yeah, doesn't really matter. And the null hypothesis is mu. You could write it as the opposite of less than, which is greater or equals to 2 weeks, or even equals to 2 weeks. And we have here to test if on average, again average, a computer technician needs 3 hours to identify a computer problem. So average equals to 3 hours, and the alternative would be the opposite of this, which is not equals to 3 hours. A restaurant manager claims that the mean, okay, again the mean waiting time for all, so all population mean, all customers in his restaurant before being served does not exceed 1 minute. Okay, this is interesting. Does not exceed. What does it mean? Does not exceed. So we have exceed or greater than, we have equals to, and we also have less than. Does not exceed means we don't want it to exceed, which means we want both of these, which is equal and less than. So equals, less or equals to contains the equal sign. This goes to the null hypothesis. Mean does not exceed 1 minute, right? And the alternative would be mu, the opposite of this, which is greater than 1 minute. Here we have a longer passage, right? We have here 63% of parents willing to spend extra money on their children's health and education. Okay, then a random sample. So this would be your sample data. Sample data goes to your test statistics and not your hypothesis. So this one goes towards your test statistics later on. So from a random sample of 500, the survey showed that 68% of the parents are willing to spend extra money. So you would like to check whether the percentage of all parents increase. Now the first thing to check is there's nothing on average or mean here, right? So they're talking about percentage, which means that this 63% would be your population proportion, P, equals to 63% or 0.63. The question is whether the percentage has increased. This would go to your alternative, 0.63. Alternative. This is your null hypothesis. Let's talk about the errors that we tend to make during hypothesis testing. So when we draw a statistical conclusion, we can never know at that time whether we are making a correct decision or not. There are two ways in which we may be wrong in drawing our conclusions. These are called the type 1 and type 2 errors. When we do hypothesis testing, we either decide to reject the null hypothesis or not to reject the null hypothesis. Now, if we reject the null hypothesis, when the null hypothesis is false, then we would be making a correct decision. If we accept the null hypothesis, when the null hypothesis is true, then we are also making a correct decision. What happens when we reject the null hypothesis? For example, this is your rejection region, alpha. If we reject the null hypothesis when it's true, then we are committing a type 1 error. Now, the probability of committing a type 1 error is simply the probability of the rejection region, which is alpha. If we accept the null hypothesis, when the null hypothesis is false, then we are committing a type 2 error. And the probability committing a type 2 error would be the non-rejection region. So what's the property of the non-rejection region? It would be 1 minus alpha. And this is also denoted as beta. This would be 1 minus alpha and also equals to beta. So these are the steps to perform your hypothesis testing. First is to state the null and alternative hypothesis. Remember, the null hypothesis contains the equal sign. So it could be equals to, less or equals to, greater or equals to. And what are the possibilities of your alternative? Greater than, less than, not equals to, right? Okay. Next, we are going to select a distribution that we are going to use. So in your syllabus, we would focus on the normal distribution and also the t-distribution, which we will discuss later. And the next step, the third step, would be to calculate the value of your test statistics. So we are going to calculate Z star and T star. Step 4 is to determine the rejection and non-rejection region. This depends on the alternative hypothesis. This would be your right tail test, left tail test, two tail test. And finally, we'll make a decision. So when the sample size is large, what does the central limit theorem say? It says that when the sample size is large, then the sampling distribution would be approximately normally distributed. So in this case, we would be using the standard normal distribution. So the test statistics would be denoted as Z star. Let's discuss the first example. Start by identifying the null and alternative hypothesis. It's already provided in this question. The null hypothesis is mu is equals to 83. The alternative, mu is less than 83. Okay. Next step is to calculate the test statistics. Right. We need to look at the sample size. In this case, the sample size is 35, which is considered large. We would be using the normal distribution. So the test statistic is denoted as Z star equals to x bar minus mu over sigma x bar. So x bar would be 80.5 minus mu. Mu is 83 over sigma x bar. So sigma x bar would be sigma or standard deviation 15, population standard deviation, yeah, over square root of n, and n, your sample size is 35. This is equals to negative 0.9860. The next step is to determine your rejection and non-rejection regions. So how do you determine your rejection and non-rejection regions? By checking the alternative hypothesis. So this is less than. Less than would be a left tail test. Left tail test. This would be alpha. And in this case, alpha is 0.1. So how do you determine the critical value? If you still remember in your previous chapters, given the probability of a standard normal distribution, this critical value is also called the Z value. The Z alpha, in this case this is negative, right? Because the mean is 0. So negative Z alpha could be found from your statistical table. So alpha was 0.1. So this is the closest value to 0.1. So your critical value would be negative 2.8. So negative Z alpha would be negative 1.28. And finally, we would make a decision. So how do we make a decision? You would compare your test statistics with your rejection and non-rejection region. So where does your test statistic fall in this distribution? It is definitely more than negative 1.28. So it falls somewhere here, which means your test statistic Z star falls in the non-rejection region. So in this case, if this is the non-rejection region, then we accept the null hypothesis. If your test statistic falls in the rejection region, then we reject the null hypothesis. Okay? So in this case, non-rejection region means we accept the null hypothesis. So we accept the null hypothesis. That means we accept this, which says that mu is equals to 83. So that is our conclusion or decision. Mu is equals to 83. That's it. We start by identifying the null and alternative hypothesis. So the null hypothesis is provided here. Mu is 50. The alternative, mu is greater than 50. Next step, calculate the test statistic. Alright, we need to know your sample size. Sample size is large, so we'll be using your standard normal distribution, Z star, X bar, 51.5 minus mu 50 over sigma X bar. Now, in this case, sigma is not provided, you only have the sample standard deviation. So we'll be using that. 4.2 divided by square root of n, square root of 40. And your test statistics says 2.2588. The third step would be to determine the rejection and non-rejection regions. So how do we determine the rejection region? By checking out the alternative. This is greater than, definitely it's on your right hand side. This would be alpha. How much is alpha? 5%, so 0.05. What's the next step? To determine your critical value by checking out your statistical table. Now there are many ways to determine your critical value, right? Just now we had 5% here, 0.05. What you could do is to determine the critical value on your left hand side, because the mean is 0. So in that case, you will be checking out for the value of 0.05, the probability of 0.05 here. Or another way of doing it, which is how I'm going to do it, is by checking out the value on my left hand side. So if this is 0.05, this would be 1 minus 0.05, which is 0.95. So the area here is 0.95. The area is the probability. The probability is denoted in this area. So 0.95, we have two values which are close to 0.95, which is 0.9495 and 0.9505. So in this case, I'm going to, both cases are correct, but I would be selecting 1.64 as my critical point. 1.64. Okay, I think you're ready for a more challenging question. So when you come across a passage like this, you would be extracting the important information. The first one is the word average here, so we have mu and not p as the null and alternative. A computer technician needs at least 3.2 hours to solve a problem on troubleshooting. Then a random sample of 30 computers is taken, so n is 30. And it is found that the technician needs an average of 2.8 hours. Now, we come across the word average twice here. The first one here, 3.2, and the second one, 2.8. What is the difference between these two averages? Right, this average refers to the average of the sample of 30 computers. That means the sample average is x bar, 2.8. And this would be the population average at least 3.2. Let's discuss about the word at least. At least would be greater or equals to 3.2, correct? And because it has the equal sign, this goes to the null hypothesis. Then definitely the alternative would be the opposite of greater or equals to, which is less than 3.2. And again, I would like to bring your attention to the word at least, which is similar to the word minimum here. Or otherwise, we have another word here, which is the opposite of at least, which is at most. And at most is the same as the word maximum. If at least is greater or equals to, then at most would be less or equals to. Right, let's continue then. You have your standard deviation. This is the sample standard deviation of 0.14 hours. Okay, so this is the first step. And the second step would be the test statistics. So the test statistics depends on the number of samples. The sample size is large, so we'll be using the normal distribution, x bar minus mu 3.2 over s over square root of n. And the value is negative 15.6492. The next step is the rejection and non-rejection region. This depends on the alternative. Less than is on your left hand side and alpha is 0.01. So to determine the critical value, we'd be checking out your statistical table, the normal distribution table. So alpha is 0.01, the property is 0.01, closest value is the one here, and the z value is negative 2.33, be negative 2.33, and then we would make a decision. So your test statistic falls in the rejection region, somewhere here. So make a decision. Z star falls in the rejection region, and so we reject the null hypothesis. We are going to reject the null hypothesis. That means we are accepting the alternative. And the next statement would be to answer the question here. What can you conclude? And so we have to look at the original claim. The claim is on average, a computer technician needs at least. So this is the claim, right? At least, this is at least. And this is less than. I would write it this way, right? Your conclusion would be a computer technician needs, instead of at least, I would write it as less than. Less than 3.2 hours to solve a troubleshooting problem. So again, we extract the information, step number 1, extract the information and writing out the null and alternative hypothesis. So an engineer wants to check if it's true that vehicles with ABS will take on average, so mu, exactly 25.4 seconds to stop. A random sample, so the sample size is 40 and gives the mean. So the mean comes from the sample, this will be x bar 26.2, and a standard deviation comes from the sample, this would be s 2.3. So can you help the engineer to make a conclusion? So what is the alternative? The alternative would be the opposite of equals to, which is not equals 25.4. That's the first step. And the second step is the test statistics. So the sample size is large, you'll be using your Z star x bar minus mu 25.4 over s over square root of n. How much is this? 2.1998. Okay, so the third step is to determine the rejection and non-rejection region. Now, by looking at your alternative, not equals to would be two-tailed test. And this is no more alpha but alpha over 2. So 0.03 divided by 2 is 0.015. So you have two critical values. I'm going to check the one on your left hand side. So we'll check for the probability of 0.015. So in the property 0.015, your Z is negative 2.17. Negative Z is negative 2.17. And Z is 2.17. Finally, step number 4, we will be making a decision. So your test statistic falls in the somewhere here, right? In the rejection region. Z star falls in the rejection region. And so we reject your null hypothesis. Reject your null hypothesis, meaning we accept the alternative. So the third statement would be to answer the question, can you help the engineer to make a conclusion? So is it true that the vehicle with ABS will take on average exactly 25.4 seconds to stop? And this is not true. So this is how I write out my conclusion. A vehicle with ABS will not take on average exactly 25.4 seconds to stop. That's it. Right, we have another example. What does it say? It says that a sample of 130. So we extract the information. The sample size is 130. Long distance calls placed through a company produce a mean. So the mean comes from the sample. This would be X bar. The standard deviation comes from the sample. So S. Right. The average length of all, this would be the population means. This must be your hypothesis. All long distance calls, the average, mu. The average of all long distance calls placed through this company in 2000 was 12.64 minutes. So using 5% significance level, this is your alpha. Can you conclude that the mean length of all current long distance calls is different from 12.64? Different. So that would be not equals to 12.64. And this would be equals to 12.64. And the next step would be your test statistics. Depending on the sample size, this would be Z star. So X bar 13.91 minus mu 12.64 over S over square root of N. This would be 5.3041. The next step is the rejection and non-rejection region. This would be a two-tailed test depending on the alternative, and your rejection region would be alpha over 2. So 5% divided by 2 would be 2.5%, 0.025. 0.025. Let's check your statistical table. The probability is 0.025. So the Z value is negative 1.96. You're very familiar with this. So negative Z alpha over 2 would be negative 1.96. And Z alpha over 2 would be 1.96. And now we could make a decision. So 5.3041 falls in the rejection region. Z star falls in the rejection region. So we reject the null hypothesis. Reject the null hypothesis. And we will be answering the question, can you conclude that the mean length is different from 12.64. Yes, it is different from 12.64. This is what we accept. So I would write the mean length of long distance calls is different from 12.64 minutes. Please remember that you would have to include all three sentences in your exams, right? Okay, that's it for now. Thank you so much for your attention.